cooking? We're cooking. All right, so your fix was we had to do excludes, right? Yeah. And we had to do it. Where did we have to do exclude? Do we have to do
player function?
Add player or in the player?
Player yeah.
Objects?
When you go down a little bit.
In this guy?
Yeah, so whenever you have a function that reference...
Core, this guy?
Not no. Get name, I think, and you go up.
Well, let's see. So get name, that's just returning a string. I would think that this get current room, since that returns this core thing, that would require it. All right, so just as a quick reminder, let's go ahead and run this guy. And we'll see it. So the problem seems to be whenever you have that Firebase is looking at functions. And when you have a function that is trying to do something with a persistent object that would be stored in Firebase, like we have with core, it starts having that same loop issue. So if you remember from core here, we're storing the entire dungeon in core. So in a player where we are letting them get the current room, where we're grabbing the dungeons, which has a collection of rooms, and then getting the room from the index, it's then going and trying to get the dungeon, which then has a player in it, which then gets the dungeon, which then has a player in it, so on and so forth. That might actually be the argument if you weren't adding a player anywhere in yours, why it wasn't having the issue. All right, so let me open up Logcat here. So we saw that it has some issues. All right, so in get current room here, we have to do, what is it, a @ symbol exclude?
I have to import it.
Yeah. So that guy. So Firebase has a database exclude thing. So this tells us to exclude this particular thing. Do we actually need to put it anyplace else?
I don't think we need to set it. Yeah, I think it's only this.
For right now, but we do need to consider any other place that we put it. Yeah, NPCs. We do this here. So we do. It probably would not crash right now because we're not actually using NPCs, but we will need it. So this will kind of prove his point. Let's just make sure it. Well, I'll just let it run real quick. Worst of the case, it adds stuff to my database. All right, so it is running now. Yeah, we see we have a couple of players in there because I doubled it up in the database. I didn't delete my database first. Now, let's get to my database. Let's do a refresh here real quick. Yeah, so a room does have a collection of players in it. It almost seems like if we're not going to store players, we should probably do an exclude on that too, on rooms, in terms of database storage. Because I think we would have to make the decision whether we want our database to just hold the structure of our dungeon or hold the current state of the dungeon. So that means that whenever a player leaves one room and goes into a different room, the state of the dungeon would change, which means that we would update our database, removing the player from one room, adding the player to another room. I'm not sure that's really the purpose of the database. You know, I feel like the purpose of our database is to hold our dungeon structure so that when we relaunch the application, we can pull the entire dungeon back down. with the idea that maybe we kind of have a dungeon builder tool that allows you to kind of create rooms and things like that, and maybe we'll look at doing that for, instead of having to hard code in your stuff, you can actually create a room to the north and a room to the west and so on and so forth. So having a tool like that, and then when you start up the game, being able to put a player in the entrance there or wherever the player previously logged out, that's where maybe the database does come into play. But you probably wouldn't store it like this. Instead, you would store a separate list of players, probably with their authentication credentials when they logged in with their username and password. You'd probably also store the room index number where they last logged out, so that when they log back in, you can grab from their profile that, oh, they logged out in room 17. So when they log back in, let's go ahead and toss them in room 17, rather than store where that player lives in the structure here. Does that kind of make sense? So with that in mind, let me go ahead and I'm going to, let me just delete the dungeon here for a second. So let's now go into room. And let's do our exclude on our array of players. And hopefully that works very similarly. So if we go to room, and here's our array of players. NPCs, that's part of the structure of our dungeon, right? So we'll probably leave that there. I'm kind of thinking that even if we make NPCs kind of be able to autonomously move from room to room to room to room, maybe when the server first starts up, the NPCs are kind of put back to their starting places. It feels like it's part of the structure of the dungeon when we place non-player characters throughout the dungeon. That makes sense? Okay, so this is kind of our problem-solving process of deciding what belongs in a database versus what doesn't. All right, so these decisions can go either way, but these are important kind of real-world decisions that we'd have to make. So just to make sure we understand how this is working, we're going to go ahead and do an exclude there before players, and I assume that it only does it for the very next line. Let's find out if that's the case, or did we just wipe out all of our variables?
It works exactly the same as the Java annotation. So
I think it's one line. Yeah. Let's just make sure that that's the case before we make that assumption. So our intention here is that when rooms get stored in our database, we're using their exclude notation here, that this guy will not actually make his way onto the database because that isn't part of the structure that we intend to store. Make sense? Okay, so let's see if that rings true. Database is currently empty. Let me just make sure that we are indeed putting a player in a room. I believe we are. Let's just confirm that. Yep, we are adding a player, so should be good there. So I'll go ahead and run this. Okay, it is launched. It is interesting that we do have two players showing up there.
maybe it's not refreshed.
But there weren't two players stored before. If I go south, then I go north. We must be adding him twice.
Oh, yeah.
Yeah, we are. We're adding him up here, and then we're also adding him down there to the CS hallway.
Well, if you add it from the department, it will tell them which style it goes.
Yeah, right. So we're going to take it away from CS hallway here. Let's run it again, make sure we only have one in there. Okay, only have one guy in there now. We maybe just wrote a bunch of stuff to the database, but let's find out. Should have just overwritten what was there. So we have our CS department. We have our rooms. Here's a room. That's not what I hoped. I wanted players to be ignored. How do we ignore an individual field?
Well, maybe Because you have return players down there.
Oh. So maybe we have to. So here's get players. So maybe exclude this. So any place that we are potentially working with players, we can exclude. We'll leave NPCs, leave exits. That's adding an exit. This is taking an exit, which does use players. So probably exclude that. That doesn't really have anything to do with database storage. Here's adding and removing players. This is the same thing.
I just go private functions.
Oh, you don't think private functions are okay, well, we can test it. Add player. Remove player. NPCs are fine. Add NPC, remove NPC. Okay. I assume we wouldn't need to do it for our constructor. Well, let's see. Well, yeah. We'll add to it as we. All right. Well, it still runs. Let me try dumping this just in case. When it overwrote, it didn't overwrite everything. Just give ourselves a fresh copy of the database. Okay, he does not have rooms now. I'm sorry, he does not have players. So this seems to be what we wanted it to be. Now, what's interesting here is because it made that change after I ran it, I want to go back. Let's delete it, and I want to remove the excludes from the functions.
Okay.
And I want to just have the exclude on the field and see if that covers it. Because this had a different behavior once I deleted the dungeon and let it recreate it. So let's dump this. Then we can put them back on those couple of functions. Because it would be most convenient for us to just say, I don't want you to take this into consideration in one place and not have to change it in any function that uses that. So we'll dump the exclude here. We'll dump the exclude here. The exclude there and the exclude there. Okay. So now, and our database is currently empty, let's see if players came back or if they remain there. I want to say we maybe already had tested this.
Yeah, this is the first iteration.
But it's possible we didn't delete the database first. No. Yeah, so the problem was I made the assumption that if the database was already there, we wrote to it, it would overwrite the whole thing. When the problem is it only overwrote the portions that we changed. So players remain. So this is convenient. This says if I don't want it to keep track of a certain one of our public fields, I could just exclude that one field and it covers it across the board for that object. All right, that's positive.
Is that going to be a quiz?
Say this again?
Is that going to be a quiz?
Well, before this thing, only Muath would have passed it. He said you spent 6 hours on it, right? That was after the hackathon.
After that,
You came home and see? We had a good time at the hackathon. It was a pretty weird hackathon. We didn't write any code. It's like a strange hack. It was more like a I called it an entrepreneurial workshop where you got put into different groups with different people to do ideation for ideas. So, like we had this cool thing. The very first one was, which was interesting. The question the group was trying to answer was, we had this thing that says, it's like blank, but for blank. And you came up and you pulled two things out of like a hat. And my group got, it's like Fitbit, but for couch shopping. So we had to create a product, the idea of a product. We didn't actually implement it, but the idea of a product for that. What was your group's?
well, Wallpapers and Snapshot.
So it's like Snapchat for wallpaper
Wallpapers.
for shopping for wallpapers, something like that. What was your?
I think we had, it's like Oculus Rift, but for hiring and contractor.
Okay, so like these weird ideas. That was probably the one that was the most fun, I thought, out of all of them. Yeah, the other ones got kind of, I don't know, weird, but
Repetitive.
yeah. But we came home with some prizes. You won a couple of things.
Yeah, there's chocolate and water.
Yeah, I won a couple of things, and then my team got second place, and then Josh Curcio won at least a couple of things, and then his team got first place. So, yeah, we had a good time, even though it wasn't a hackathon. Okay, so now we have this thing where our dungeon, we have a dungeon structure, and this feels like it's probably, let's go ahead and create an NPC and just make sure they get stored. We'll throw the NPC in a room. And then what we're going to do is we're going to pause this project, and we're going to go create a second project that talks to the same database. And the purpose of the second project is going to be for managing our dungeons, building a dungeon. So we'll assume we only have one dungeon at first. That way we don't have to have a whole select the dungeon you want to manage. Let's just write the base tool of, I want to add a room to the north. I want to add a room to the west, that type of thing. So we're going to attempt to build this dungeon we have here, but build it out more than we currently have because the rooms already exist. Okay. So let's add an NPC and just make sure our dungeon structure currently works for that. Let's see, when I create my dungeon, this is in main activity, build dungeon. Let's go ahead and let's create an NPC monster is equal to a new NPC. He's a monster. He'll be a monster in one of the rooms. So we'll put Locklear in one of the rooms. And then what were we doing? Okay, so then we're gonna we'll put him in this room. So we'll say s120.add NPC monster. All right, so now we should have a NPC in this room. Let's go ahead and dump our database for now, just to make sure it gets rebuilt in the right way. We shouldn't have to, because NPCs we want to be in there.
Oh.
Yeah, NPCs are going to be part of the structure of our.
From the room perspective, but from the NPCs themselves, the function of NPCs, it should take off the.
Oh, his current room? No, this is an int. We're okay.
In get, I think set current room.
Let's try it. I don't think that's going to break it. Let's give it a shot. We'll know real quick. Did break it. So because this guy returned an actual room, I don't think we need to do it for set current room. Just this one, yeah. So because this guy returns an action, he's a public function that returns a persistent object that we are storing in Firebase, we need to exclude that.
If I'm reading it correctly, it's just getters and setters, so we could change it to grab current room, make it technically not a getter, and
I don't know, because a getter doesn't require this naming convention.
oh, doesn't it?
No. That's just the common naming convention. Okay. Yeah, so this is effectively a getter and setter because he's returning a room, unless they're looking for that specific naming convention, which I would be surprising. All right, so here's rooms. This is the room that guy was in. Here's the NPC, and there's our monster. Okay, So that looks like it's a reasonable structure for our database without spending a zillion hours figuring out this perfect model or something like that. So now let's go ahead and we're going to create a second project, but that interfaces with the identical database. Okay? So we have our game, which allows a player to play. We're going to add attacks and things like that into that we've already kind of started. But then we're going to have our dungeon builder app that is for the admins only, and we'll open this app up, and that way we don't have to either programmatically write all our rooms or go into the database and make little modifications. Instead, we are saying, oh, well, we're going to write the entire database to the screen. That makes sense? Now, one thing we will want to do from this point forward, though, is we're going to have inside of our main activity here, when we build our dungeon, we're no longer going to build the individual objects because our dungeon is actually stored in the database. So we want to pull our dungeon in from the database and build the objects from what the database says we should build. Does that make sense? So this was kind of our starting point to show us how we can build a dungeon using the objects and stuff and then store those. But if I comment that out, and so now the way we're going to build our dungeon is different. Now we're going to build our dungeon by creating a listener that hits Firebase, pulls down the current state of our dungeon, and then builds out our dungeon. Okay? Now, if I open up, I'm just going to open up that second project. Open recent. Here's the Firebase Starter. I'm going to create this in a new window so they're both open here. And we'll go and look at, in our main activity, up top here is where we created our listener. So we had our reference to our database, and then we added a value event listener. And we put in here on data changed. So we can have a couple of different, there's a couple of different ways we can do this. So what this guy does is he'll get called automatically any time that the database changes, and he'll update it. Now the reality is that whenever we change the database in, that might require a server reboot because we probably don't want to have our rooms update in real time. So just thinking about it from a video game perspective, there isn't a reason why we couldn't necessarily do that. It would probably add some complexity to how we update our dungeon because when you first do this and you read in your entire dungeon, you build your couple of rooms and those kind of things. Now let's say players have been playing this for an hour, so players are strewn all about our dungeon. And then all of a sudden, somebody on the dungeon builder team, the admin people, they change the database. Or somebody goes in and changes the database directly, changes the name of a room or something like that. Well, changing the name of the room might not be the end of the world, because then if a player's sitting there, all of a sudden they just see the name of where they are change. But that's just the beginning. You could change where that room, like where the east exit goes. So you might go to the east thinking you're going to go to one place, when actually you go to the east and now you're halfway across the continent or something like that in a big dungeon. So having a dungeon update in real time might not be the way you want a game to work. The idea is that maybe you have a test. Most games, they kind of have a test server, and then they have the real server. And on that test server is where they're, seeing if new mechanics and new things actually work. And then as soon as they say, yeah, we're happy with this, then they do a patch day or something like that, where at the very least, the main server is rebooting and rereading in the new dungeon map. That type of thing. So as soon as our server starts up, that's when we grab the current state of the dungeon, and that doesn't change until our server restarts. Now at this point, we don't even have a server. At this point, our server is our single app that we only have one player in our world at a time. All right, so we'll hopefully have time to add a little server where we can have two apps connected to the same world at once. So it'll be the server that's in charge of grabbing the current state of the database, then handing it to the the two objects that connect. But if we don't get there, that's not the end of the world. We're trying to practice with database type stuff here. Okay, so we can add our value event listener and go ahead and grab the current state of the dungeon, but then we probably don't want to get any additional information there. So I'm going to go back over to this project, and we already had, I think we have our, nope, we put it all down in here. So down here is where we actually get our Firebase stuff. So I'll say Firebase database, Firebase dungeon ref. We should already have our dungeon. So I'll just pull those couple of things outside here. So this is going to be our reference to our, well, this is the reference to Firebase. Here's the reference to our specific dungeon. We only have one dungeon in there, and we can make that assumption for right now. All right, so now we want to take that reference, this dungeon ref, and we want to add a listener. Now, the single listener for single value event is, I think, going to be different than add value event listener. Add value event listener will get called any time that the dungeon gets called. So let's write it this way first, since we've already written this previously, and then we'll try to update it to the other one, because we really only want to ever hit the database regarding our dungeon structure once. So even though Firebase is a real-time database, and anytime something changes, it'll let us know about that change, which might be helpful for us. For right now, that's not the way we're going to do it. Even as I say that one of the nice things about Firebase for this type of thing would be that Firebase can act as your server. If we bring players back into Firebase, when a player leaves one room, if he lets Firebase know he left that room, Firebase would then let all connected clients know that that player left that room and is now in a different room. So you actually can have Firebase keep track of players. I know a few minutes ago I said that maybe we wouldn't want to do that, right? That, maybe we only want to store the actual structure of our dungeon in Firebase. But if we take advantage of the fact, if we're thinking ahead and saying, oh, we might have multiple players that live in our dungeon, we might want to, at least eventually, go ahead and let Firebase start storing the current location of players too. And every single time a player leaves one room and enters another room, that would actually change the state of the dungeon on Firebase. Now, that in and of itself might seem like what's the point? But the big kicker for Firebase is because it's a real-time database. If one Android, so if we're thinking that we're all in this game, right? We're all playing this game from our Android phones. It's one thing if I'm just the only one playing and I go from one room to another. I know where I am. The database didn't have to store that information. But if I hit north and my guy leaves the current room and goes to the room to the north, if that information got updated in the database, what would automatically happen from Firebase is it would push those changes to all of you. So then all of you could then update your maps to now have the new players that are in those rooms. Does that kind of make sense? So historically, we would have had to have written all that logic in our own kind of secondary server, where we could actually leverage Firebase to do this for us. I think that actually could be helpful. It's just like we got to choose by number here. What happens next? Do we store players and then make sure our database lets us know about that change?
Yeah, how else can you keep track of
See, this actually then even becomes a cooler use of Firebase. Because right now we're looking at, let's go ahead and add this at the top level so we can talk about this in constructively. So I'm going to add a value event listener to this guy. I expected it to do more than that for me. Add value event listener. That's all he's going to do for me. And thought it was going to. So we'll, oh, I bet you it's the piece in here, new value event listener, that it'll give me the, and what's going to go in here is going to be a new value event listener. And that's when it creates all these things for us. And initially, it's going to give me a on data change thing. It's going to give me this thing called a data snapshot. Now, all I'm going to do right now is I'm going to do a system.out.println data snapshot dot, I guess toString. I thought there was like a debug. toString probably gives us something that looks okay. We'll see. All right, so here's our link to our database. Here's our reference to the top level, which is our dungeon. And that's going to be an important piece for where I'm going with this next. Then for this top level, we're saying I want to be notified whenever anything changes anywhere in my dungeon. Okay, this guy will get all those notifications. Now, initially, our dungeon's just there. It's already stored in the database, so we see it over here. This is our dungeon. So when this thing first runs, it will get an initial data snapshot that will just print out right here. We'll process it next, but we're just going to print it out right here. And this guy will show us the JSON structure of our database. Okay? Proving that we are reading in our database from Firebase. So we're going to leave it like that. Remember, we have all of our other stuff commented out right now, so our dungeon, our database isn't going to have much, well, our game isn't going to have anything in it, but we should at least see that we will get stuff from our database. So we'll go ahead and run this. Somebody's mad because we need to have a semicolon there. Oh, one more thing I need to comment out. Let's not try to add a player to a dungeon that was never actually built. Because we're not building the dungeon yet. So just take those couple things out. We'll just call this one function build dungeon and let it do its thing. Which right now is just print out the structure. Okay, so here is our dungeon. Can I just close this for right now? There we go. So here's our dungeon. Whole bunch of JSON crap in here. Here's our NPCs, blah, blah, blah. So there's all the JSON coming from our dungeon. Now what we'd want to do is we want to now piece apart that JSON and build out our dungeon objects. So if we think about this, we are definitely going to be creating a brand new dungeon, right? So when we say build dungeon, what were we doing before? Right here is where we were building the brand new dungeon. So we're going to build a new dungeon, and that dungeon is going to have, where's our dungeon's name? Here's our dungeons, here's value. Oh, was that the very end of it? Yeah. So we have the name of our CS department. So we're going to need this for building our dungeon. Now, the reality here is, though, is that what we were actually storing before is the dungeon, right? So what we should be able to do is we should be able to go ahead and say, create a dungeon from this. So if we go back and look at our other example here, when we read stuff in, I created a dungeon. So in this case, I created a user. And I said, get the value from this snapshot. So this snapshot has one value in it. The very first child is our only dungeon, right? Because we're really holding a collection of dungeons. And the very first dungeon that's in there is our only dungeon for us. Okay, so we want child 0 from our objects there. So in this case, I'm going through all the children that are in here. All I need is data snapshot.getChildren.getFirst or bucket 0, whatever the syntax is for that. All right, so we'll get that very, 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 very first dungeon. And then we'll go ahead and build a dungeon object and ask that child to give us his value as a dungeon.class, which hopefully builds out our dungeon, because we built our dungeon in terms of persistent objects that live in Firebase. All right, so inside of main activity, data snapshot is going to get us our top level thing here. So I'm going to go ahead and say data snapshot, I'm going to call this guy the dungeon, is equal to data snapshot dot, there's get children dot, so that's an iterative thing. Can we just get first child? This guy gets me a child with a name. And we're not necessarily going to know the name of that child. We have a unique name for it. So I think the way to do this is to iterate over all the children, and after the first one, break out.
Oh, the string is a path. Can you give it a path?
Yeah, but the path is this unique thing here.
Oh.
So I don't necessarily know that right now. I might be able to, can I say snapshot.get, get key is not going to get it. So get children. I'm really surprised I can't do more with that.
What is key? Maybe you can get the path?
Well, no, because this is all the children. Iterator dot next, which would be the first thing. I think that'll do it. And this guy is a data snapshot. All right, so our dungeon is going to be a portion of what was read in. Which portion? We're going to take our full data snapshot. We're going to get all the children. We're going to get the iterator associated with that, which is effectively a built-in for loop. So remember, we use that in the other thing. It says go over all the children, and it builds us an iterator for that. And then I'm going to say just give me the very first thing, which should give me the dungeon at bucket 0 of our of what was read in here. Okay, so that's our dungeon. Then we'll go ahead and say we can build the same thing we built before. I'll steal that line. Except it's not going to be a new dungeon like that. Do we not have a CS department up there anymore? Yeah, we do. We're okay. So we're going to let this guy... Oh, this is the problem we had before. This dot is not the instance of main activity we're in. It's actually the instance of this value event listener. So if you remember from when we were going over this before the hackathon, we have to give ourselves a little hack variable here. So I can say private main activity, let's call it main activity instance pointer. I know that's a little bit verbose here. And this guy is going to be of type main activity. And then what I'll do here inside of onCreate is I'll say this dot main activity instance pointer is equal to this. So now I have a synonym for that. And because all variables resolve to their most local definition, I can just say main activity instance pointer right here, and that will get me the CS department. So the most local definition of main activity instance pointer is actually the guy that lives way up here. But the most local definition of this is the this associated with this particular value event listener. So it's the wrong this from our perspective. All right, so we're going to set the CS department associated with our particular instance of main activity instance pointer, which we set to this up here. So effectively, main activity instance pointer and this, from the perspective of main activity, are synonyms. Does that make sense? It's a pretty important concept, so if it doesn't make sense, tell me it doesn't make sense. Because it might not make sense. You may draw a picture?
Yeah, but I don't understand how it still have access to the new pointer you made.
Because this guy right here is a local scope within that more global scope.
Oh, so it's just we don't have a
Yeah.
keyword for it.
Let me draw a picture. I think the picture will help. I'm getting a lot of blank stares with no participation. So let's am I reading the room right? Is that a pretty accurate thing? All right. Just for the record, and when I say does that make sense, it's valid to say no. I lost you 20 minutes ago. That is a valid response. Otherwise, I'm just piling more detail on top of like quicksand, right? All right, so let's draw it this way. So we have our instance of main activity. All right, and I'm going to do that and that with that guy. Okay, so when our thing starts up, we have a main activity. Okay, we're good with that? Then, now main activity has associated with it a variable called this. And from that perspective, this is this particular instance of main activity. Okay? Now, at a later point in time, we have a value event listener, close enough. All right, and our value event listener also has a variable called this. This particular instance of value event listener. Okay? So if we are in here, and we say this dot, here, let me throw the CS department up here as well. So this guy also had our dungeon CS department. Like this. If I say this dot CS department, and then whatever equals some stuff, right? The most local definition here of this is this one right here, which is my instance of value event listener. When I really meant this. This, that, this. That makes sense? I have two variables here, both called this. All variables resolve to their most local definition. When I say this right here, its most local definition is this guy right here, which is the instance of value event listener, which isn't what I actually want. I want to have the instance of main activity. So now the only way I can get to main activity from here is if I do a little hack up here. If I say main activity instance pointer is what I called it, and I happen to set that guy to this. So the variable main activity instance pointer, his value is equal to this. All variables resolve to their most local definition. So the most local definition of this right here is this associated with main activity. So a pointer to the actual instance of main activity. And I'm storing that inside of this variable called main activity instance pointer.
If we called main activity instead of this,
That's the class name.
oh, it's not an instance.
Yeah, I need an instance of the class. So now if I say that guy dot CS department, all variables resolve to their most local definition. Main activity instance pointer, this guy right here, it's going to check locally here and say, do I have one of those guys? I don't. So it bounces up a level and says, I found him right here. And what is his value? It's the memory address that was associated with main activity. See how we made a hack there? I mean, we didn't break any rules, just we gave ourselves a variable whose value is synonymous with this from the main activities perspective. That way, when we resolved it right here, it would work. So this kind of required us to really understand those scoping rules. All right. This concept here is a really, really important concept when you're doing application development. Okay? And it's something that inexperienced developers get hung up on for hours and hours and hours and hours. Now, what could you have done? You could have thrown it up in your singleton. Say, have a variable up there called my instance of main activity, and then say core dot my instance of main activity in here, and then we'd have access to it, right? It's completely plausible. It's no big deal. But you got to get to it somehow. And the fact is that if we are inside of the implementation of an instance of Value Event Listener, because understand, this is a little bit foreign to us. When we have this implementation of an object in line inside of here, that's weird for us, right? If you remember when we were looking at the example here in our starter thing, I wrote two versions of this. In our message listener, I created a brand new class called Message Listener, and this guy implements Value Event Listener. So in this case, it makes more sense. Where if I'm inside of a class called Message Listener and I use a variable called this, I'm talking about this instance of Message Listener. It's pretty clear cut then, right? That's what this is inside of a class called Message Listener. But when I was out here in main activity, now let's just go to our main activity here since I know exactly where it's at in here. if I say this dot, we might be inclined to believe that this is this particular instance of main activity because that's the class we're currently in. Or at least that's the class we think we're currently in. But the reality is the class that we're currently in is actually our inline class that is an instance of Value Event Listener. Anybody remember what we called this when we pass, in this case, an entire class definition to a function? What does it mean to pass a function into another function? What's that word, that vocabulary word associated with that? That'll make a good quiz too.
Recursion.
The who?
Recursion.
Recursion is when a function calls itself from within itself. In this case, I'm having a function take as a parameter another function. It is an interface, but it's not. An interface is what I'm building in there. Starts with a C. L, CL. Dude, I think we played this identical game last time where I started spelling it out. Do you remember that? Okay, we should write it down this time. CLO? S? Who? Are you going to cheat?
Well, I need to make sure that I wrote it down.
Well, you could write it down this time. It's called a closure.
I thought closure was
I
spelled
don't
with a
remember
J.
writing that.
Huh?
I thought closure was spelled with a J.
Closure with a J. All right, so it's called a closure when a function takes another function as a parameter. In this case, we're taking an instance of a class as a parameter, so I'm using that term function kind of loosely. In languages like JavaScript, this is pretty common if you're a web developer using JavaScript, they typically won't use that kind of theory term closure. Instead, they'll call it a callback. So a lot of functions, or a lot of programming languages that take a function as a parameter, the purpose of that function is to call back. So you're saying, hey, look, maybe I'm giving Charlie something to do. You're running some errands for me. Okay? And at the end, I'm handing him a function. I'm saying, call this function when you're done. That's his callback to me. So realistically, it might be I give him my phone number and say, text me when you're done. But that's the function. You call this function and it texts me. Okay? So that's where that callback idea came from. Go and do your stuff, go and do your logic, and when you're done, call this function. That's the callback. Okay, so callbacks in languages, like they're really popular in JavaScript, which then means they're also very, very, very popular in Node.js. And when you guys get dumped out into industry and you start writing software, well, you might not be writing Android apps. You might not be writing iOS apps. You might be a Node.js developer. Who knows, right? Whoever's going to pay you the big bucks, right? So when you get into that, callbacks are all over the place in Node.js because it's called a superset of JavaScript, as well as a whole platform itself. But regardless, callbacks are an important thing in programming implementation, and they're an example of the computer science theory called a closure. Make sense? All right, that would make a good quiz. I almost feel like I probably said that last time. See, the real problem here is I just say so much great stuff. Yeah, it's recording. Yeah, it's in one of those things where it's like there's too much crap up here on the screen because of all the menus that it gets pushed off. So it's there. Because you wanted to make sure it didn't miss me saying I say so much great stuff. I sometimes feel I have more fun in here than you do. That's not the way it's supposed to be, right? Isn't it supposed to be exciting to be spending all this money to learn? That's a loaded question. All right. So, in any case, do we, where's my picture? Do we understand this concept now? That this, and this are different thises? And depending on where I am in the code, if I'm writing some stuff inside the implementation of Value Event Listener, and I say this, I might be inclined to believe it's actually main activities this if I'm using this kind of shortcut implementation where inside of main activity, I'm actually generating an instance of Value Event Listener. Well, I'm generating the class and an instance. I know I'm making an instance because I have the new keyword here, right? But instead of just calling, here's the no argument constructor, I'm also saying, here's the entire class definition right after that. So I'm taking kind of a shortcut, but that shortcut can also then be misleading. I personally don't really like this syntax. In this particular case, since we're kind of just doing a one-off thing, it makes sense. But if I was using the same Value Event Listener in many, many places in my code, you'd want to make that its own class and then just create an instance of it wherever you need it. But in this particular case, since we are going to have different Value Event Listeners depending on who I'm interested, because rooms are different than NPCs, are different than dungeons. We're kind of listening to events that are talking to Firebase, but what I'm doing with the information I get from that is different. I'm not doing the identical stuff. In some cases, I'm building a dungeon. In other cases, I might be building a user, whatever, that kind of stuff. Building a room, let's say. So with that in mind, this kind of approach makes sense. But this kind of approach, if I remember back when I first learned this stuff, can be kind of intimidating. It's almost like a scary chunk of code. Is that an accurate kind of assessment? Yeah, we get too many curly braces in a very compressed section, it becomes intimidating. So just to dumb it down, there's no difference between this and creating my own class that implements Value Event Listener and putting that identical structure in there. And then here just saying new my Value Event Listener. And that's it. This is just kind of a shortcut inline kind of version of this. That also then opens us up to this problem that we're looking at here, where sometimes we can be fooled into what this actually points to. Because from our perspective, like, oh, we're in main activity. We kind of forgot that we're actually inside the implementation of another class right here. Okay, so everybody's cool with this picture now?
Can main activity access any variables inside that closure? For example, the dungeon right now, can you access it outside?
Well, it already lives outside. I put it out here. Where'd I put it? I put it right here.
Oh, no. The snapshot, the dungeon.
I understand what you're saying. This guy down here. This, wherever I'm creating it. This dude right here?
Yes.
No, well, the answer is no. He wouldn't have, and let's draw the picture just to close the gap. So we have inside of here, we have another variable here called the dungeon. All right, which is a data snapshot. That guy. All right, so his question is, I have a local variable inside of this particular instance of Value Event Listener. Do I have access to that inside of main activity? The answer is no. This is no different than this guy here being a function that lives inside of main activity, and this function having a local variable. I have some int count inside of the function. That guy lives and dies with that function. Now, having said that, if I needed him to be exposed to it, I maybe could have thrown this in a closure, or make him a variable up here that I just accessed down here. You can make it work, but as I have it defined now, I am defining the dungeon right here in its entirety. So that guy is a local variable. Actually, he's a local variable specifically inside of the onDataChanged function. So I wouldn't even have access to that up here in my Value Event Listener. He lives and dies with this one function call. All right, makes some sense. So I get that this can be kind of an intimidating thing, but actually what we're talking about here is just scoping rules. where you have access to variables. This is just more of a little bit less cut and dry than we're used to. Okay, so because I can't say this dot in here and mean my instance of main activity, I've given myself this main activity instance pointer. I really spelled it out what this guy is, which is a synonym for this from the perspective of main activity. All right, I gave that to myself right up here, where I set main activity instance pointer equal to whatever this is right here. That's just going to be a memory address. Okay? So now I can say that guy dot CS department, I'm going to have him equal, and this is where we're going to go ahead and grab the value from our data snapshot. So if I come down in here, we're going to ask that instance or that data snapshot to give me a value, and that value is in this format. So for us, it's going to be dungeon.class. And the name of my child, I think I called the dungeon or something like that. Yeah, I called it the dungeon. So I'm going to say the dungeon dot get value, and the value that I'm getting is a value of dungeon dot class. Let me hide this stuff here. All right. So remember, the dungeon, this data snapshot, is a sub snapshot of my big one. So data snapshot here is the entire database. I'm saying give me all the children of the entire database, which will be my list of dungeons. Right now I only have one thing in that list. Then give me the iterator, the ability to go through that entire list. Then give me the very first element, which should be the one element that's in there, which is my pointer to my computer, my CS department. So that's what the dungeon is. And then I'm going to set my CS department dungeon variable equal to the dungeon, which is this snapshot, dot get the value. But I want to get the value not as a string, not as a Boolean, but I want to get it as a dungeon class. And the hope is this puts together my entire dungeon for me. All right. Then after that, I can go ahead, presumably, and I can add the player here. Well, let me just steal these two lines. And then I can fill my interface. Except what I need to do is instead of saying this here, I need to say the name of my pointer up there. Same thing here. So after I have CS department filled with something, then I can go ahead and add my player, which I've previously created, correct? Yeah, here's my player. So before I even built the dungeon, I built my player. So I'll go ahead and add the player, and then I'll go ahead and update my interface with stuff. So we might actually notice, because this thing here is happening what's called asynchronously. What does it mean for something to happen asynchronously as opposed to synchronously? We'll throw this in our notes. I'm sure I've mentioned it at some point before, but it might not have been in this class. Here, we'll throw closure in here. So this is the function that is passed. I'll put function that is passed to another function as a parameter. That's what a closure is. All right, so now we're thinking about asynchronous versus synchronous. Synchronous. There. All right. The bad thing is, I know what these concepts all mean, but I can't spell them. That's the sad thing.
Shortcut, async.
Well, yeah, but then you wouldn't know what they're, I mean, yeah. All right, so we're talking about asynchronous versus synchronous calls. Now, maybe you've heard me refer to it, you certainly have from 450, but I'm going to go ahead and say synchronous is equal to a blocking call. That is a call that blocks. It doesn't let us get past that until something else happens. So for instance, if I'm asking Charlie for his phone number, I don't move on with the rest of my life until he delivers me my answer, right? So if he's just staring at me like a deer in the headlights, I'm just waiting. Okay, make sense? All right, that's a synchronous thing. An asynchronous thing would mean non-blocking. So I asked Charlie for his phone number, and while I'm waiting for that to come in, I can move on with my life and do something else, and eventually I get that answer. Okay? So synchronous is blocking. Asynchronous is not blocking. We can also think of this as happening at, let's say multiple things happening at once. An example of how we implement asynchronous stuff is through threads. So creating multiple threads allows us to have things that occur asynchronously on a computer. This is one thing happening at once. And we can say no threads, although modern operating systems, every process has one main thread. We just don't have any more threads other than that. Okay, so when we say something is synchronous, we're saying that it is happening only at once. So this class is a synchronous class. Let's take it away from computer programming. That means that this class meets meets twice a week, but once in a day. And if you want to get this class, you have to show up in person to the class, right? That's a synchronous delivery of a class. An asynchronous delivery of a class would mean I have all the lectures recorded, and you never show up to class, and you can watch them whenever you want, right? We don't have to be in the same place at the same time. The material has been created. You can absorb that material when you want to absorb it. That would be an asynchronous delivery of a class. That makes sense? So these words don't just specifically link to programming. It goes deeper than that. Okay, so point is that this stuff here is happening asynchronously. I'm setting up this value event listener, so all this stuff takes, let's call it a hundredth of a second to set up, but I don't have my data yet. I move on with life. So after I've done that, I bounce up here. So the last thing I did is I called build dungeon. Now, before I get my information from my dungeon, I've moved on here. So I'm probably going to show my default dungeon at first. My default screen with nothing filled in, because I haven't actually filled my interface. It would be dangerous for me to add a player to CS Department right here, because more than likely, I don't have a value inside of CS Department yet. It's coming in a moment, because we have to wait for We've registered with Firebase. Now we have to wait for that guy to give me my initial dump of data over the internet. Okay? So that's why I've put the fill interface and the add player inside of here after I've received my callback from Firebase. All right. Give it the old college try here. All right, it was trying to add stuff on our array list here. Here's player, perform action, room.
I have to create the room before the dungeon.
I wouldn't think so, because I would think that creating the dungeon would create the rooms. That's part of the reason of storing it in Firebase. one thing I'm thinking here is, oh, I know the exact problem. It's calling this constructor first. So I need to at least give myself exits, and this dot exits is equal to new array list of exit. I need to give myself those empty array lists. And this is room. All right. There might be similar things to that. Let's just try it real quick with this, and then we'll fix the rest up next class. Yeah, same problem in room. So we would have to do the exact same thing in room. Our empty constructor here needs to have the array list for our NPCs, those types of things. All right, so let's just leave it here for now. Risk of quiz on Thursday. Some of the things we talked about today. So go back, review the video, that kind of stuff, because I think we said a lot of really good things today. We'll finish patching this up. I think this is going to work fine. Just remember when we talked about the Firebase tutorial before the hackathon, when we're reading stuff in, it's always calling that no argument constructor first and then filling the stuff in after that. So we need to make sure we give ourselves default values for all of our stuff. That way it has something, like specifically with the array list, something to put something into. Okay? So we'll leave the error for now, let it pick up. I'll go ahead and push this in case you want to review the code for Thursday, and I will see everybody on Thursday. Bible homework is already up. It was up, I think, yesterday or whatever. Remember today, student, faculty, staff, Bible study, God and Grub. Go to the cafeteria, sign in, get your free lunch, take it down to the terrace room, and go to Bible study. I won't be there today. All right, one second. Let me stop this and get it uploading.